Hello everyone, I'm Tanya Ganguly and today my project is based upon image classification using TensorFlow deep learning. Here first of all, as you can see, I have loaded the important libraries and imported TensorFlow. After importing all the libraries, I have downloaded the dataset. It's almost, as you have seen, I mentioned here, there are almost 3670 images of flowers. If you want, we can check it, the image count. Now, I have tried to test the data set of roses. Basically, first we will create the data set, then we will build up a model, then we will train, then we will test, and then again we will bring up the necessary changes and then again predict with a new data set. Okay, I'll show you one more. Now, this particular data set has different flowers titled roses, tulips, daisy, dandelion, sunflowers, etc. I have also tried to trace some tulips. See, exploring the data set is a very much essential part of doing a programming because then you will understand what your data set is and what your main objective is of your particular program. And as the title here is mentioned, image classification, so this required steps are very much essential for oneself. As you can see, we are getting the tulips. After that, I have created a data set where I have defined some folders, like parameters basically for the loader. And then I have tried to use a validation split while developing my model. Now I have used 80% of the images for training and 20% for validation. Training data set, validation data set, 5 total classes are there. And then we can also rearrange the directory names in alphabetical order using the class name attribute. And as you can see, daisy, dandelion, roses, sunflowers, and tulips are the 5 main classes of this particular data set. Then I have tried to visualize the data. Here, there are first 9 images from the training data set where I have roses, dandelion, tulips, sunflowers, dandelion, roses, tulips. After that, I've tried to batch them, label them. After that, I have tried to auto tune them. After doing that, I've tried to standardize the data. Basically, you have the RGB format range from 0 to 255. But here, what I'm trying to do, I am trying to bring it to 0 and 1. So I've done the normalization layer, and after that, I've trained the data set. And as you can see, 0, 0.0, 1.0. The data has been standardized. After standardization of the data, I have created the model. After creation of the model, I have compiled the model. Here I am using Adam Optimizer. After that, I have used the summary method to find out the model summary. After that, I have trained the model. After that, I've tried to visualize the training results. And as you can see, there is a wide difference between training accuracy and validation accuracy here. So we need to minimize this error and make it a better model. So for that, I have gone through all the particular respective key features of this particular graph, and I have discovered that it's an overfitting. So to overcome overfitting, I have here used data augmentation and dropout method. So performing the data augmentation here. After that, I have tried to visualize what a few augmented examples look like by applying data augmentation to the same image, same particular image several times. As you can see, this is one particular image where data augmentation is performed many times. After that, I will use this data augmentation part to train a model in a moment later on. But before that, I have also tried to drop out using the dropout method, where basically what it does is like it will bring up to 0.1%, 0.2%, 0.1, 0.2, 0.4, like 10%, 20%, 40% of the from the entire data. Basically, it will remove some parts, remove some images, and reduce the length. So I've done the dropout method here, I've used it. And after that, I have compiled and trained the model. After compilation and training of the model, I tried to get the summary. Again, I have trained the model. And after that, I have tried to visualize the training data result. And here what I can see is the training accuracy and validation accuracy is much better now, because here as you can see there is a vast difference between these two here. But after performing data augmentation and dropout methods, I have overcome this particular problem, or I have come up with a good model, and this is my result. After that, I have tried to predict with a new data set, and which has given me a confidence level of 93.83%. The most important thing you need to remember is data augmentation and dropout layers are inactive at interference time. So I hope I was able to give you a proper explanation of what my project is and how has this project helped to build up a model, and accordingly it has tried to detect and give us a proper result. That's all from my side. Thank you so much.